Hello everyone, our next experiment is O3, refractive index of the prism. The aim of this experiment to determine the refractive index of the prism. Before we find the formula for obtaining the refractive index of the prism, what will we do first is we are going to find out the angle of the prism and the angle of the minimum deviation. So in this experiment, actually there will be two-part measurement. First, measurement of angle prism A. Second, for measurement of angle deviation dm. Let's start for the first part, measurement of angle of prism. First, we should know what is the angle of the prism. For this, we take a prism. Look at the prism sketch in the picture in this video. As you can see there, we are looking at triangular side A, B, and C. Now we have A as the angle of the prism. If a light is coming from P in a straight length, it should move to continuous straight line, but because of the prism, it deviates and reaches the pathways of PQR. In this way, if we draw and interpolate the incident light till outcoming light, we will have a complete light propagation pathways. We can analyze each angle based on angle principle calculation. Starting from incident light angle I1 and refractive angle of P R1 and incoming light angle from inside the prism as I2 and R2 as refractive angle for outcoming rays. So from the mathematical analysis on correlation, we will have the angle of the prism A equal to R1 plus R2, and for deviation angle D is the sum of I1 plus I2 minus A. Okay. If we have I1 equal to R2 and R1 is equal to I2, which is R1 is a half of A, then we can analyze again the D, the deviation angle equal to 2I1 minus A, which is I1 become A plus dm over 2. And based on the formula of the refractive index equal to sinus I1 over sinus I2, then we have the formula for determining the refractive index of the prism. In the right side of the slide in the picture, you can see the schematically set up for the measurement from the natrium lamp and then collimator, and also the standing holder of the prism, and also the telescope, and which including the vernier scale. Material and tools: the prism, natrium lamp, spectrometer. The procedure: the first, make sure the spectrometer in the adjusting and a correct position, and also check the natrium light source, and also the vernier scale. Put the prism on the optical bench. This is the first part for measuring the angle of the prism A. And then after you place the prism as in figure 1, look for the refractive rays and note the position of the theta 1 in the right position, and you have to turn the optical bands so that the yellow line is at the very edge, and also you have to measure in the left side too. After that, put in the previous position, and this is for the second part, is for the measuring the deviation angle. After you turn around the prism, you have to measuring the position and reading the vernier scale. Note that the angle theta 1 and theta 2 of both position of the telescope to the right and the left of the straight direction where the light is coming from for each of this position, its deviation minimum, and you have to do for the right position also, and take a look for the difference value of them. Okay, here is the data. The first table here is the measurement of the peak angle of the prism. You will get theta 1 in the right side and the theta 2 in the left side, and after that you have to find the difference between theta 1 and theta 2 as 2a, and then the a is a half of the difference between theta 1 and theta 2. And the second table is the data for the measuring the minimum deviation angle. You will also get theta 1 in the right position and theta 2 the left position, and also you have to calculate the difference between theta 1 and theta 2 as 2 dm. So the deviation minimum dm is a half of the difference between both of those angles. Here is your task. You have to determine the refractive index of the prism. After you get the calculation and the measurement result from your data, you have to make the discussion in your report. In the end, thank you so much for your attention. See you in our next experiment, and good luck.